Let's also look at the force of friction. So the way friction works is it always opposes the motion of two surfaces in contact. It's always present, and it can take any value up to a maximum. And when we calculate friction, what we're doing is we're calculating the maximum value. That maximum value can be found by this formula. The force of friction equals mu, which is the coefficient of friction, times Fn, which is the normal force. So let's do this. Let's take the two examples from the previous slide and calculate the maximum values of friction for each if mu, this is the Greek letter mu, if mu is equal to 0.2. In the first case, you'll recall that our normal force, or Fn, was equal to 980 newtons. And so, in this, the force of friction is equal to mu times Fn. And so, the force of friction equals mu of 0.2 times the force of friction from the first example, which was 980 newtons. So 0.2 times 980 newtons, which equals 196 newtons. So in the first case, if you were pushing that box across the floor, friction could take a maximum value of 196 newtons. So actually, let's look at what that means. Here's flat floor and the box. And let's say that you were pushing with only 20 newtons of force. Now, anywhere up to a push of the maximum force of friction, so you can push anywhere up to 196 newtons, this box won't move. Why? Because friction will oppose it up to 196 newtons. So if you push 20 newtons, it won't move. Why? Because friction will oppose that up to 196. In this case, it'll oppose it with 20 newtons of force. Friction can take any value up to that maximum. If you increase your push to 50 newtons, friction will increase to 50 newtons. Still won't move. If you increase your push to 120 newtons, friction will increase to 120 newtons, still won't move. If you push at 196, friction will oppose again at 196, its maximum value. If you push with 196.0001, however, the force of friction will stay at 196 because that's its maximum value, and this will start accelerating in the direction that you're pushing. In part B of this question, Fn equals 921 newtons. And so on the ramp, pardon me, on the ramp, the force of friction will equal mu times Fn, which will equal 0.2 times 921 newtons, which will equal 184 newtons, opposite to whatever motion you are trying to put to that object. Let's do another problem. A body experiences the following forces. It experiences a push of 19 newtons to the east and 22 newtons to the south. Let's first find, let's call this A, the net force acting on the object. Let's call this part B. If the object has a mass of 130 kilograms but experiences no friction, let's find its acceleration. We'll call this part C. If the surface has a coefficient of friction of 0.005, what will the new net force be? And D, what will its new acceleration be if it's experiencing this friction? So in part A, let's do some vector addition. We have a force acting to the east of 19 newtons and a force acting to the south of 22 newtons. And the F net will be the sum of those forces. You'll recall from math that when you're adding vectors, that when we add vectors, we add them tip to tail, and in this case, these are at 90 degrees. So we can use the Pythagorean theorem to figure out the magnitude of this F net. And so let's do that. According to the Pythagorean theorem, F net, the square of F net, will equal 19 squared plus 21 squared, plus 22 squared. So F net will equal the square root of 19 newtons squared plus 22 newtons squared, which will equal the square root of 361 newtons squared plus 484 newtons squared, which will equal the square root of 845 square newtons, which means that F net, if you take the square root of 845 square newtons, let's actually take the square root. Will equal 29.07 newtons. F net equals 29.07 newtons. In part B, we're asked to find the acceleration of that object. And so let's start with this. F net equals ma. It's an equal sign, equals ma. If F net equals ma, that means that acceleration equals F net divided by mass. So the acceleration will equal 29.07 newtons divided by its mass of 130 kilograms. Now, let's in fact change newtons and say that the F net is equal to 29.07 kilogram meters per second squared, and divide that by its mass of 130 kg. Now, looking at the units, kg cancels top and bottom, and we'll be left with units of meters per second squared. Since we're looking for an area, that's good because because we're looking for an acceleration, that's good because acceleration does come in units of meters per second squared. If we ended up with an acceleration with units of kilogram meters per second or something like that, then we'd know that we were on the wrong track and something had gone wrong. So doing this math, 29.07 divided by 130 equals 0.22 meters per second squared. You know what I forgot to do? I forgot to find the direction of this net force, which will also be the direction of this acceleration. So let's do that. If you look at this, because this is a right angle triangle, we can use some trig. And relative to this theta, 22 newtons, this is the opposite side, 19 newtons is the adjacent side, F net 29.07 newtons is the hypotenuse of this triangle. Now what I'm going to do, what I suggest you do, is use these given figures to calculate the angle theta. This is because if you use the hypotenuse, the calculated hypotenuse, then if you made a mistake here, you're also going to get that angle wrong. If you use these given figures and do the math properly, then that won't be a problem. So, looking at this theta, tan theta equals opposite over adjacent. Okay. So we'll say that tan theta equals opposite over adjacent equals 22 newtons divided by 19 newtons and so tan theta equals 1.158. Now this decimal goes on for a really long time, and what I'm not going to do, I'm writing 1.158. In fact, this actually goes 1.1579 on and on and on. What I'm going to do for the calculation is I'm going to leave all of the decimal points, all of the decimal places in. I'm just going to write 1.158 for the sake of brevity. But when I calculate theta, I'm actually going to use the whole long number. I'm going to inverse tan 1.1579 on and on. And the inverse of that tells me that the angle theta is equal to 49.1 degrees. Now, that's this angle here. That's not the angle that we're going to report, because 49.1 degrees, depending on the system that you're using, would either be on the Cartesian plane up this way. If you were saying that you're going in the direction 49.1 degrees, it'd be in that direction. We don't want that. We want this direction over here. Right? So, being that this is south, and I'm going to erase this guy, all of this stuff, so we don't get confused. Given that this is 49.1 degrees, and here's east and here's south, I'll give the direction as 49.1 degrees south of east. This is also because this guy is equal to 40.9 degrees here. This angle right here is equal to 40.9 degrees. You could also report it as south 40.9 degrees east. That is to say, south and go 40.9 degrees towards the east. So this net force is south 40.9 degrees east, and this acceleration is also south 40.9 degrees east. Now in part C of this question, we're asked to find the new net force if the coefficient of friction is 0.005. So in order to find the new net force, we'll have to calculate the force of friction. And the force of friction equals mu Fn, which equals 0.005 times because this is sitting on level ground, the Fn will equal the Fg. The Fn will be opposing the force of gravity, and thus will be equal to the force of gravity. And so Fn will equal mass of 130 kilograms times acceleration due to gravity, 9.8 meters per second squared. And so doing that math, we get a force of friction of 6.37 newtons. Now, we know that the force of friction opposes motion, and so that means that the force of friction will be exactly in the opposite direction. So the net force will equal 29.07 newtons, the new net force, minus 6.37 newtons. Why minus? Because this is in exactly the opposite direction. The minus, when you're talking about vectors, is just means opposite direction. And so our new net force, taking into account friction, will be 22.7 newtons in the direction south, 40.1 degrees to the east. And lastly, we're asked to find the new acceleration once we take friction into account. And so, given that Fnet equals mass times acceleration, we can rearrange that to say that acceleration equals Fnet divided by mass, which equals 22.7 newtons in the direction south, 40.1 degrees east, divided by mass of 130 kilograms, which will give us an acceleration of 0.17 meters per second squared in the direction south, 40.1 degrees east.